Hello YouTube, today we're going to calibrate the Shapeoko 3. This is the standard size, but the procedure would hold the same for an XL or an XXL. Apologize up front for the video of the computer monitor. Haven't dug into screen capture yet, but hope to do that on some upcoming videos. Alright, so what we have here laid out is a pattern. The procedure is basically we've got a known distance here, right? So this is 4 inches and this is 4 inches. We're going to drill these 4 pockets, and we are going to measure with our calipers this distance and this distance. This should set up the X and Y calibration. I'm not going to worry about Z. You would do Z the same way, although you would use a step height change, right, or drill a known pocket depth. So may cover that in a later video, but for now we're just going to do the X and Y. So we're going to drill those 4 pockets. We're going to measure the crossways distance and the up and down distance, or in this case the X distance and the Y distance. And then we're going to do some calculations, which I hope to put on the screen, and then we are going to enter those values into gerbil and as new values. Okay, little explanation on what's going on here. The Shapeoko 3 uses what's called stepper motors. Stepper motor, think of it as breaking up one rotation of the motor into many steps. What we're doing here is telling it 1 inch on our table surface, 1 inch on our table surface here, or this way, 1 inch on our table surface is equal to so many steps. The default for that is 40.00000, right? So 40 motor steps equals 1 inch. We don't know that. The belt tension, the exact motion of the gantry and these different dimensions, that might be 39.999 steps or 40.0001 steps, right? We don't know exactly how many steps is an inch. So that's what we're going to do. We're going to measure it, we're going to calculate it, and then we're going to tell gerbil, hey, 1 inch is exactly X number of steps, and then hopefully we should end up with a better calibrated machine, more precise. A little bit about how precise we're going to get. I'm doing wood and wood applications right now, so I'm going to be happy with anything under at or under 5/1000ths of an inch, right? And I think I'm already there. The first few test cuts that I did showed that I was within that 5/1000ths, but we'll go through the process anyways. If you're doing metal, if you're doing high precision metal fitting, 5/1000ths would be way outside of what you'd want. But for wood and wood applications, think about it this way. A 1/8 of an inch, 0.125. A 1/16 of an inch, 0.0625. A 32nd of an inch, 0.03 something, 0.032125, right? A 64th of an inch is about 15/1000ths. We're talking about a third of a 64th of an inch, right? So less than the thickness of a sheet of paper that we're going to be off. For wood applications, that's probably good. A couple passes with a sander and you're going to take off more than that. So that's what we're going to do. Let's get to it. Okay, as you can see, we got our piece chucked up here. We got it clamped down. It's just a piece of MDF that I got going here. Scrap. I like using MDF because it's very dimensionally stable. so I don't have to worry about the edges bowing in or out or anything like that. It should make a pretty good clean cut. You can see my dust boot on there. Just made that. Seems to be working pretty good. And I've got hooked up to my central dust vac, my central dust collection. Seems to be working well. So let's cut the pockets. Here you can see our holes. Now what we're going to do is measure those, right? We're assuming that they are exactly 4 inches apart. What we're going to measure is see what we get for an actual. So there. Let's see what we get. So in this direction we are 4.006. So a little long. And in this direction, we're also 4.006. Okay, so that's good. That gives us something to go back with. All right. So now what we need to do is take that measurement, and hopefully I'm going to be able to figure out how to put a graphic up here to do this. But basically, what we want to do is say the 40.00, right, is going too long. That means that it's actually less than 40 steps to go an inch, right? So I want to figure out what that ratio is. So I would take 40.00000 and divide by 40.006, and that's going to give me a 3.99999 something. We'll actually do the math and put that in. But that ratio, that division that we're going to come up with is what we're going to put into Gerbil to calibrate, to tell the system, hey, this is not exactly 40 steps, it's actually slightly less than 40 steps. So how do you do that? Well, okay, we're going to go to MDI, right? We can send code directly to Gerbil, and what we're going to put in here is the following. Okay, here are the commands that we're going to use. I needed to pull them up. So for this $100 equals 40, this is now 40 for the Shapeoko 3. This is the X, this is the Y, this is the Z. They're all originally 40. As you, we're going to tell that our scaling factor now, or our scaled result, not the scaling factor, right? So we're going to tell it not 40. We're going to tell it $100 equals 39.9400899. And 101 equals 39.9400899. Okay? So let's go back and do that. So in here we've got four zero zero 899. And 101 equals 3, and should be okay. All right. So now let's set up and run it again and measure it and see if we did any better. So we're going to run the program again and see what we get. All I did this time was offset the center a little bit, so it's going to make another set of circles that are slightly shifted, and we'll just measure those.